This is question 10. It is from the November paper 2017, paper 1 for standard level, and it's non-calc. And we're told we've got a following diagram, AB, with length 2. The line is divided into an infinite number of line segments. The diagram shows the first 3 segments. So the first segment is P. The second segment is P squared. The third segment is P cubed, and it's divided into an infinite number of segments, so the next segment would be P to the 4, P to the 5, and it's going to keep going, and okay. And the length of the segments are P squared, P cubed, where P is between 0 and 1. Okay, so that's quite important. Show that P is equal to 2 over 3. So I can tell that if I was to take these segments, P, and if I was to add them up, plus P squared, plus P cubed, plus P to the 4, and so on, all infinite amount, that would equal, so if I was to take all these segments, P plus P squared plus P cubed plus P to the 4 plus P to the 5, and there is an infinite amount of them, they would equal 2. And this is a geometric sequence, because if I look at it, what do I multiply the first term by to get the next term? I multiply it by P. P times P is P squared. Multiply P squared by P, and I get P cubed. Multiply P cubed by P, and I get P to the 4. So we've got a geometric sequence, and our first term, U1, is equal to P, and our common ratio is also P. First term and our common ratio. So I am summing an infinite number of terms, so I need to sum to infinity, and this formula is given to you in the formula booklet, which is U1 over 1 minus R, because I want to sum up all of these things. So first term is P divided by 1 minus P, but I know if I do add all of these terms up, it's going to equal 2, because I'm adding up all of these terms, and it's going to equal the same length as this, which is 2. And what I'll do next is, I've got an equation now in terms of P, I will solve it, and hopefully it will equal 2/3. So in order to solve this, I'm going to multiply both sides by 1 minus P. So I get P on the left-hand side, and then 2 times 1 minus P. I'm just going to take this up here. Obviously you would write it underneath, but I just want to get it all on the one page. So I've got P equals, expand the bracket, 2 minus 2P. I'm going to group my P's together, so add 2P to both sides. P plus 2P is 3P. This is looking good. That all equals 2. Divide both sides by 3, and I end up with P equals 2/3 as required. So it's a sequences question. Okay, so for part B, I'm thinking it's going to be similar, hopefully. So 1 sec, just make this a little bit bigger. So we've got the following diagram, CD, with length B, and B is greater than 1, and we're told squares with sides length K, so this is K, so this means that this has to be K because it's a square, K squared, so that means that this is K squared, and this is K cubed, so this is K cubed, and then the next one would be K to the 4, and so on, and K is between 0 and 1 are drawn along CD. The process is carried on indefinitely. We've got the first 3 squares. The total sum of the areas of the squares is 9 over 16. So let's write down what the areas of each of these squares is. So we've got K times K is K squared. So that's the area of this square. The area of this square is K squared times K squared, which is K to the 4. The area of this is, excuse me, k cubed times k cubed, which is k to the 6. The area of this one would be k to the 4 times k to the 4, which would be k to the 8. So remember your rules of indices, you add the indices when you're multiplying. And if I know that the total sum of the squares is equal to 9 over 16, so if I was to add up these areas, and this sequence is going to keep going indefinitely, the sum is going to add up to 9 over 16. Now this is again another geometric sequence. I can see that my first term is equal to k squared. I can see, what do I multiply k squared by to get k to the 4? I multiply it by k squared. What do I multiply k to the 4 by to get k to the 6? I multiply it by k squared. So my ratio is k squared. And if I want to sum up all these values, and I use my formula again, I'm summing to infinity because there's an infinite number of them. I'll write the formula, u1 over 1 minus r. u1 is k squared over 1 minus k squared, and I know that the sum of all of the areas equals 9 over 16. So, although I have to work out what b is, a good starting point is to figure out what k is first. So I'll do exactly the same thing as I did before. I'm going to multiply through by 1 minus k squared. Actually, what I'll do is a little bit of cross multiplication. So I'm going to take all of this, multiply by the 9, take the 16, multiply by the k squared. Alright, so I've got 16 k squared equals 9 times 1 minus k squared. Okay, so just cross multiplied. And now I will expand the bracket. 9 minus 9k squared. I'm going to add 9k squared to both sides. I'm just checking my work here. I think that's all okay. So that's 25k squared is equal to 9. Divide both sides by 25. So k squared is equal to 9 over 25. Take the square root. So k is equal to square root of 9 is 3. Square root of 25 is 5. And k has to be between 0 and 1. So k is equal to, so technically this is positive and negative, but k has to be the positive value, as k is between 0 and 1. Okay, now I need to work out what this CD is. And let's think about that. Yeah, so this is actually similar to the previous question. Wait, just have a look up here. Yep, p squared, p cubed. Yeah, because if I look at this, I can see that k, it's just using different letters. K plus k squared. So I'm just looking at the length here. K plus k squared plus k cubed plus k to the 4, etc. If I add up those indefinitely, that's going to equal this length, which is b. And yeah, I can see from this that, let's see, can I use the previous answer? I don't think so. No. So we'll just keep going with what we've got. I know that k is 3 over 5. So I've got 3 over 5. The next term in the sequence is 3 over 5 squared. The next term in the sequence is 3 over 5 cubed. So we're doing exactly the same thing again. It's a geometric sequence with first term 3/5, common ratio 3/5, because 3/5 times 3/5 gives me 3/5 squared. 3/5 squared times 3/5 is 3/5 cubed. And I want to sum these up indefinitely, because when I do, it's going to equal b. So using the formula again, I've got it up here. So u1 is 3/5 divided by 1 minus 3/5, and this is equal to b. I'll just move my, so I've got 3/5 divided by 1 take away 3/5 is 2/5, because that's 5 over 5. 5 take away 3 is 2. And if you're not happy with it looking like this, I've got 3/5 divided by 2/5. Keep, change, flip, and that gives me the 5's cancel, 3 over 2, which is equal to b. So that's a 9-mark question, okay? And you're basically doing summing an infinite geometric sequence 3 times. Please let me know how you get on. If you need any help or any assistance, just send me an email, okay?